I'm just fascinated by all that's going on and moved by it really, because this is for those of us who imagine things like the maker movement being impactful in the world. This is just such a clear demonstration of what good people can do given tools and expertise and working together. And I think the latter is probably the real secret here that I want to talk about. Because we could all geek out about designs and that kind of stuff, but it's really the mobilizing other people. I was going to suggest that we start with Lars. I'm always interested, how did it get started? How did the response begin? You know, who was figuring this out, and how did it begin to get organized? So Lars, could I ask you to introduce yourself and just give me some of that information?
Yeah, morning, Dale. So I'm Lars Torres. I serve as Executive Director at the Artisans Asylum in Somerville, Massachusetts. We're a 42,000 square foot member-powered fabrication wonderland, as I like to call it. Makerspace to most people, but really a collection of studios, dreams, tools, and products that have been cultivated, brought together over the last 10 years. We were founded by Guy Cavalcanti back in 2010, who was an engineer and a big thinker. One of the things that I think is kind of extraordinary is that he began talking about this pandemic and about the opportunity for makers to respond probably late February, maybe it was early March. Sarah can tell you a little bit more, but he stood up a group that grew very rapidly. There's a group called the Open Source. I think it was out of that our community really began to look at the opportunity. And what we did at the asylum is the organization, independent of what members do, because when you have that hive mind, there are a lot of opportunities to put it to use. So as an organization, our opportunity is to say, okay, well, where should we focus? And what we began to do is talk with local doctors, healthcare providers, and others and say, what looks like it's going to be the acute need here? And we very quickly identified gowns, hospital gowns. We identified facial masks. And of course, that's what was in the press as well. And then face shields as items that local hospitals and healthcare providers were willing to pay for, which was important to us because we don't have tons of cash coming out of our ears. So we had to figure out a model to be engaged that we could afford to be engaged in. And, you know, selling this material at cost was pretty important for that model.
Can I ask you, before we go into the solution space,
Yeah.
what did you learn about why there were shortages of these three things in the hospitals?
I think what we learned, the essence of that story, is a breakdown in supply domestically, as in a lot of this was being produced overseas, and there was a huge global demand, not only for the product, but for the raw materials that made the product. And nobody here really saw that coming and had an adequate response to it. I think the federal government tried to deploy stockpiles from various military in Cuba and elsewhere, but it was insufficient. And the logistic problem, standing that up overnight, was overwhelming.
Which came first, the gowns or the face shields? In terms of,
I'll hand this over to the team and they can talk about their own individual journeys.
Yeah.
But, for sure, what we don't have represented here are face shields. And because of the work at the University of Wisconsin and one of our members, Josh Beckman, we were able to stand up that team very quickly. And the first order for 1,000 shields came through a member who then handed the sort of like the stewardship of that product line, if you will, over to the organization long term. But it came probably in late March. Maybe we fulfilled it April 1st even. And it was,
so that was a local hospital?
Yes, Cambridge Health Alliance. Cambridge. Yeah, we produced it, but really directly from the University of Wisconsin's work. So what's helpful there is we could stand up the story of production based on what they had done on the early prototyping, iteration. Tim, Sarah, others had to do a much, much deeper dive into the design and the manufacturing process itself, which is why those just took a little while longer to get stood up.
I think that first week of finding out the coronavirus was hitting the world in a very fast pace, kept all of us glued to our screens. And as we kind of uncovered and was watching it unfold around the world, the idea that a lot of these face shields, masks, and protective gear actually came from like the Wuhan area. And so as those factories shut down, there was a direct need. And then as more and more countries were in need of those exact safety precautions and safety gowns that were normally distributed worldwide. Each country needed them. We're like, oh my God, it's going to be a while before this is replenished. As we watched this group called Open Source COVID-19 Medical Supplies grow from about 500 of us to within 1 week, it was like 6,000, 10,000, 15,000, 20,000. You could see people all over the US starting to just jump in. Tim, I remember you were making immediately, starting to 3D print immediately because it became apparent that face masks were necessary, and the first go-to move was to 3D print. Within a week, we kind of knew that maybe that wasn't the fastest way, but over the next 2 weeks, watching people at Artisans Asylum jump in with 3D printers, laser cutters, and start to nationally watch through this group different ideas be uncovered, tested, and then new iterations coming out, and then people settling on them and saying, okay, it's been a week. We've tried out 27 different designs. This one seems to be able to be made the fastest. What are the hospitals saying? What is it like to go through the procurement department? What process legally where do we fall? Who's going through the front door? Who's going through the back door kind of things? Meant that there was teams here saying, hey, do you want to build 3D printers? Do you want to do with laser cutters? And then somebody said gowns. And so after having that first 2 weeks of experience, we were able to jump in very quickly because we had seen the whole process unfold.
To be clear, you're a member at Artisans Asylum?
Yes.
And prior to the pandemic, what kind of work were you doing there?
So I'm an industrial designer, so I make one-offs and prototypes. So this kind of thing is very, it's my job to jump in and take this one item and then make many more of them. It's the idea of, hey, can you make this thing that we don't really have the means to make right now? Can you reverse engineer it? Can you source materials? Can you set up a line of people that want to make a certain amount of them? And we are under tight deadlines with restricted budget. We basically need a miracle. That's kind of working for startups.
Yeah.
And making prototypes for startups has made this pretty easy.
Can I actually talk about reverse engineering a gown?
So for us, I had 6 gowns given to me from the area. I made sure that they came in plastic bags from different hospitals, and then we went through them. So there are 3 main suppliers of gowns nationally, and we went and found different versions of each one of those, and then found the ones that we were able to make. For instance, there was small things about the neck or the wrist. I think what was difficult was going through the AAMI requirements and making sure that we were uncovering why these designs existed and sticking to the standards, and making sure that we were producing something that was going to be nearly equivalent to what was available out there. But we couldn't source elastic, for instance. So what was really common was an elastic wrist, and getting non-latex elastic was very difficult. So we would modify the design to fit what was available to us. But that really was limited to just the wrist. Other than that, it was designing a one-piece design instead of separate sleeves. So we chose the designs that had the least amount of manufacturing problems and the least amount of work. So,
right. How about the basic material? How about the material of the gown? Was that hard to source?
Yeah, all the gowns that we found that were 100% polypropylene spun bound, and it was a matter of giving them to the hospitals, giving the materials to the hospitals and saying, which of these do you approve of? And once we got approvals back on the materials that we had offered, we went forward with those, and we were able to find them out
in enough quantity. Yeah.
Yeah, I'm like, hey, look, we just got 6.
Is that behind you? Is that what that is?
Yeah, those are.
I was wondering what was looming over your head.
That's a huge roll right there.
Yeah.
And then there's 6 more.
And where'd that come from?
It got shipped down from Canada. This material is used in a wide variety of industries, and it is not that different from exactly what's available in the medical industry currently. 100% spun bound polypropylene is a very relatively common material that you can find out there. We just had to find it.
So what tools in Artisans Asylum did you need to make gowns out of this material?
Interestingly, we tried laser cutting different patterns. We tried our plotter. We tried a CNC machine. None of those things were really fast enough, so we ended up getting a fabric saw, which is not unlike a jigsaw, but it's just a tabletop jigsaw. And you can cut many, 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 many layers at a time, like 100 to 300 layers of one pattern at a time.
I see. Great. Well, let me go over to Tim. And how did you get involved?
So as Sarah mentioned, I started off printing face shields, crucibles, like, such a nice idea and pretty easy to print. And we realized very quickly that it just wasn't scalable. So we started thinking about what these tools could be used for, and I started off with about different mask designs, in N95. Yeah, and realized that there's actually a big demand for pleated surgical style masks. And there are a couple of benefits to them. One is they can actually just be worn over an N95 or N99 respirator as a barrier, which prolongs the life. Two, wearing them out in the public where filtration is not as important as it is in a clinical setting. But sort of the real elegance to the design is that if you can build a pleated mask, you can feed that with whatever filter media you can source. And if you can only get polypropylene with, not great filter characteristics, but okay, you can make an okay mask. If you're able to source 3-ply, SMS polypropylene that's used in traditional masks, then you can make one with very good filtration characteristics. So the idea was coming up with a tool that could accommodate a variety of materials while forming the same physical shape. So for the last couple months, I've had 6 printers running just nonstop, iterating through designs. So down in the bottom corner are the most recent parts. And these are actually, they've been sold to a textile factory in New Jersey who's interested in making masks. And actually 2 minutes ago, I got a text from a different factory owner out in Worcester, Mass, who wants to purchase a pleater as well. What I discovered is that there are quite a few textile factories that have the material, or the tooling, to handle material in feed, to cut the material, to sew it or bond it. They have everything they need in the assembly line except for the pleating tool itself. So whereas with the shields and the gowns, the production is the PPE itself, in my project, the production is the tool, and it's sort of a force multiplier. If I can provide pleating tools to factories, I've been able to sell to factories that don't have the means to, or experience to print their own. But anybody who would like to, I've spoken with folks in Mexico, South Africa, and Chile who can download the files on their own and make their own.
Right.
Adapt them to different material thicknesses or widths based on whatever's available locally. So I think that, it's so key that what we're designing here, you asked earlier, like, how did we get in this point with the supply? And we became, I think, complacent. I think the medical industry just got so used to like, okay, well, I can place an order today and in a week we'll be stocked up. There's really no need to have a deep, deep reserve. And up until now, they've been getting those orders. So there's really no reason for them to think this is something they need to protect against. But it's so incredibly clear, I think, to all Americans now that we have to own the means of production. So having a democratized production method like this, I think is really crucial. Yeah. So, I'd like to think that down the road, every hospital might have one of these machines in their basement with a stock of polypropylene ready to make their own. Once this is all together, the pleating tool itself can do up to about 20,000 masks a day.
Really? That's incredible. Yeah.
Yeah, and that's just for the pleating tool, to be clear. Adding the ear loops is still a pretty manual process for us. We're working on automating that as well, but at the moment, that's the rate limiter.
Right. Tell me, how did you think about, are there a world of pleating tools out there that you found one and said, I'll reverse engineer it? Or did you kind of come up with this?
So YouTube was my friend.
Okay.
And I watched a lot of videos. Luckily, Chinese and Indian mask making manufacturers have videos where they just kind of walk around the machine and you can get a rough sense of what they're doing. So the design behind me with the stainless steel fins is closest to what's used in industry. So I just kind of customized it with my own measurements. Do you mind if I screen share for a minute? I'll
Sure. It occurs to me that we're out China-ing China. Right? This is what they did to us, and now we're doing it back to them. Right? It's how they build up their production capacities over the years.
Yeah. So this whole thing's been designed to be modular. So, one module needs to form the pleats. I don't want to be engineered into a corner if the first style of pleating tool doesn't work. So I've actually designed 6 different styles. And this is one that I'm going to show you that was really just highlights how powerful 3D printing can be. So this takes the material in after the middle pleat has been formed. And as it goes through the block, you can see this profile flips up and over itself to form all 3 pleats and then presses them down as the material exits. So in concept,
are you printing that like in slices then? Is that?
I'll show you. I'll turn one of the bodies off.
Okay.
Do the other one. So inside, what's a pretty simple idea, you actually have, really complex geometry.
Yeah.
So if we, align with the front, you can see this helix shape. I don't know if that helps.
Yeah. No, it does. It does. I couldn't visualize what was happening inside, so that's great.
Yeah, and I've done a handful of other styles, like I was saying. So this is the current model for the stainless steel finger pleater. And if you'd like, I can go through the rest if you'd like to see some of the other styles.
Yeah, sure. Just quick, I have time. And what program are you in here?
Fusion 360, which is another thing. This has been a free tool to me as a hobbyist for years. So I've been able to, tinker around and occasionally make models so that when a crisis like this comes up, I'm actually proficient in the software package. And I wouldn't have been if not for Autodesk's focus on making it an available tool for hobbyists.
Yeah, that's great. And it's something, I want to come back to if you want to continue here, but, kind of what you knew going into this and what you've had to learn. Have you ever made anything equivalent to a machine like this?
Like this? No. I've done quite a bit of 3D printing and robotics work, but as a conversion process, taking a reel of a material and folding or cutting or sealing it somehow, I've never done anything like that.
It's fascinating.
Yeah.
So what are we looking at here?
So this was a
janky pleater. I like the name.
Yeah, this was named. One of my teammates found a video on YouTube of an Indian machine, and he's like, "Hey man, I found this thing. It looks a little janky, but maybe this is what you should try." So the name stuck. The material comes in through these rollers, and each one of these steps separates the individual pleats, then lock through these fingers. So this was my first revision for printed fingers like this, and it worked fine, but there's not really much of a lead-in angle, so the material was bunching. Printing these dovetail features, they didn't slide very well, so I wound up I'll switch to our current model.
So what's the iteration time on this? You're taking something from YouTube, turning it into a design, trying to print it out and test it, right?
Yeah. So this kind of gives you a little better view of going from, first I thought I would 3D print blocks and then laser cut these fins. Then I thought I'd 3D print the whole thing. And then this was a later version with this lead-in angle. So, if I see a YouTube video for these rollers, for instance, it's pretty simple geometry. So that sketch might have taken an hour at most, and then set it on the printer, let it run overnight, and I come back in and I have a part ready to try. And so making the first version, definitely not labor intensive. Seeing where that fails and what needs to be changed to make it work a little bit more reliably, that takes some time. So for instance, in this design, I was like, well, there's not a lot of load on these rollers. They're just, there's very little force involved. I don't think I even need bearings. So I just had these spinning around on 3D printed pegs. That didn't work so well. So I modeled the next version to press fit a bearing on either side, which helped. But then the middle is not being pushed down as much. So I modeled them to be split in half and have a third bearing sitting in the middle so that you can bear down evenly across the roller. So it's that iteration process that does take more time, but each, individual step, that internal pleater took the most time. CAD on that took a couple days to really figure out how to get the helices where I wanted them. But a lot of these parts are simpler than that. So getting the first versions it hasn't been really labor intensive to get the first version of things. And for printed parts, this is the state of the art. So, instead of dovetails, like I said, I moved to 8mm rods. So it's easier to slide the fingers on and off. What's nice about this design is I can, get somebody up and running quickly with these printed parts. And then if they decide that they want stainless steel fingers, that's great, because this actually slides on to the exact same mount. It has the same hole spacing. So you can literally slide off the printed part and slide on the stainless parts and have a better pleating tool pretty quickly.
Yeah.
Hey, Tim, quick question. When did you make the decision to sort of pivot from thinking that we might be able to get the right mask fit for the product here to actually making masks? Because at some point that was a pretty clear pivot that you had to make.
Yeah, it was when I started getting requests from other factories or people who are interested in putting this tool to use. I realized that my time in the global PPE demand shortage would be better spent trying to support other people who are developing machines. That said, we still are working on a complete assembly line. I actually just had 6 new ultrasonic bonders were delivered this morning, so I'm gonna work with those. And I would like to have a complete assembly line producing masks here in-house, but I would never build a second line, if that makes sense. I think it's worth building one to make sure it works the way I expect.
And replicate it elsewhere, right?
Exactly.
Yeah. Yeah, that's terrific. Talk about the bonders. I mean, I think you showed those on the previous program. What are those?
So we were lucky enough to get through Neil an ultrasonic bonder that it has a few different attachments that let you either bond or cut material. And it works very much like a sewing machine, but it's better suited to this non-woven polypropylene. So the state we got it in, it had been wired incorrectly. It had been wired for 120 and it needed 220. So luckily our members were able to quickly figure that out and get it up and running. And then, if you guys spent a couple nights testing a bunch of different materials, so we'd have sort of a guideline for what settings, what pressures, what voltages make sense to get a really high quality bond. So it was just a lot of experimentation. Everything we've done has just been like a scrappy effort.
Yeah.
Little about this has been, oh, how convenient. That's the industry I've worked in for 30 years. This is how you do it. It's like none of that. It's like,
in some ways, you're taking people with certain skill sets, but they're learning new things and they're doing things they've never done before. I guess, Lars, how does that make you think about maybe the future of what makerspaces really are?
One of the biggest missing gaps that we've had to normalize around, with lots of pain and adaptation and patience and grace, is the business side, right?
Yeah.
But when we talk about makers and we talk about a place like the Asylum, the reason you come is because you sort of want to get away from the day job environment. All of those pesky Gantt charts and all of those accountability mechanisms and, the focus on your bottom line.
Yeah.
So what do? I tell everybody who signs up to be a part of this team that we need project management, that we have to have reliability, predictability, and validity, right? That we have to really start treating what we're doing in a way that we've never really thought about ourselves before, because we are a little bit of a pirate ship and suddenly we're trying to become, I don't know, a on-time
cruise line.
Yeah, exactly. So it's been challenging, no question about it. But the team that is stuck together, I think, is going to go far. There's a lot of potential here, and we haven't been able to say yes to every idea. Some of the people who have been said no to, that's not going to work. We're not going to do Prusa masks, for example. Some of those folks have joined other teams, and that's been this real sort of quickening process, very organic, very messy, but it's been quickening. And, we've lost some folks along the way. I hope they'll come back later for future projects and opportunities. We happen to have a board member, Nicholas Warren, who's doing a great job fulfilling orders on the hospital side. And so once you build that relationship with a hospital, once you say, yeah, put us on your schedule, we really want to be able to fulfill their orders and not let them down. And so trying to tune what we're doing internally while still being true to our culture, while at the same time fulfilling those orders with people doing life-saving work who really need them, has been the biggest stress of our culture, of our systems, of our self-identity, all that kind of good stuff. What do you guys think?
Yeah, I think Lars is totally right about that. This place is an escape. And I will say that Lars was my boss for the last year and a half. So I have a slightly different experience with Artisans Asylum in terms of Gantt charts. But I am definitely happy to be here as a maker. I think that what we're going to come out of this all with is a renewed appreciation for local fabrication skills. I think that I'm hoping that we're going to have a willingness in hospitals and other organizations to consider solutions from outside the conventional sources. So they're being forced to relax standards right now, but I'm hoping that might encourage them to see that there's a world of innovation that can provide better products in one way or another if they're not so fixed to certain standards or, proper ways of doing things. And this isn't to say that the goal is that they should use lower quality equipment. It's to say that thinking a ventilator can only be purchased from one single company that has patents locked up for decades, it doesn't necessarily have to be that way. But the most inspiring thing of all of this is just coming in day after day and seeing dozens and dozens of people for the last couple months who have had no motivation other than wanting to help their community. There's no profit seeking here. Nobody's trying to get publicity. It's just people who want to help.
Yeah.
Real quick, behind you is one of the other heroes of this movement, Pastry Queen. Can you introduce her? She's using the ultrasonic bonder. This is her best new friend behind me.
So this is the ultrasonic bonder that we've been using to make all the gowns with. We've currently made 3,000. We're going to be almost at 4,000 by tomorrow. So just some of the process here. PQ is the one in the red shirt right there. You can start to see the rollout process. And as soon as she's done talking to anybody, we're going to bring her back over here. But she is certainly the co-captain here. Dale, you were asking earlier about tools that we ended up using. This is the saw. This is the fabric saw that we ended up using.
Yeah. Nice.
And that ended up kind of being our best tool of all of the larger items that we had tried to automate with, whether that was a CNC machine. This is an example of something that we just kind of made to hold each 150-pound roll of fabric. And there's been some nice little iterations to get the patterns to work out. Some nice little tooling that was done in order to make parts of this pattern easier to cut out. It's a little bit hard to see because this pattern's clear, so I guess this is an example.
Yeah, there's a little bit of...
But so just to give you that, I was going to try to introduce PQ. She's talking to some folks. This is PQ.
Hi, PQ.
Make Magazine, and a little
flyby
of everything that we're up to over here at Artisans. And you can see it's been the one that's bonded all 3,000, nearly 4,000 of the gowns that we've been making. We're at 400 a day here. So she's been the only one that's been taking on the ultrasonic bonder.
She learned it there, right, for this job, right?
Yeah.
She didn't know how to use one previously, or...
Yeah, no, but she's a seamstress. So this is the action. So I can let this round. Tim, were you going to say something?
Yeah, I was just going to say that those the metal tools you were showing that Mark Mason built, or the frame that's holding the material that was welded. Like, I think one of the really powerful things here is, is your skill on the lathe or mill? Is your skill with a welding machine? Are you a woodworker? We have all of these people who have contributed in meaningful ways to these projects, even if the end result isn't something they touch directly. So I think that's one of the other benefits here is truly anybody can help out in this effort.
Yeah.
And one of the ways I like to think about this, Dale, is that, a makerspace can often be seen as a community amenity, right? It's like, oh, it's that nice place where, the hackers or whomever go out and hang out. But what we've seen right now, and a big story that I think Make Magazine can really promote, is that, in fact, makerspaces are essential. Yeah. And the only reason we're here doing this work that you see PQ and Sarah and Tim and others doing is because thousands of people have made very small investments over 10 years to enable this kind of community resiliency. And I think that's a headline out of this experience.
Yeah. There have been a lot of opinion pieces on, like, why are essential workers getting minimum wage? What does the word essential mean based on how our society actually values labor? And I think that when we see lots of businesses closing across the country, it's interesting to look at businesses that are doing better than ever in this space and kind of asking why. And I wouldn't say that financially we're doing better than ever right now, but we have a clearer need and a clearer role in our community than ever. And I think that this crisis totally highlights that we matter, that makerspaces matter, and that when times are good, we are a nonprofit, so it's easy to just think charity case, and we get some support, not as much as we'd like. But when things start to go badly and we're here day in, day out the way that we have been, I think that's a really powerful recognition. And to Lars's point, we were here for, 10 years before this. We didn't spring up out of nowhere.
Even though in many cases the maker spaces were closed, the networks that they had built and the skills they had developed were able to be combined. And now I almost think there's this, apart from the production side of this is kind of this really responsive public R&D facility, right? I'm particularly interested in things that don't have a business model, because I think a lot of the problems in the world don't get solved because they don't have business models.
Your community to explore the question of how do you take an effort like this that is so much powered by goodwill and volunteerism. I mean, if you had to ask Sarah right now about how many human hours had been volunteered to make the 3,500 gowns that are out there, it's got to be in the hundreds and hundreds, right? How many volunteer hours?
So we do about 40 a day, so 40 times 3 weeks, so 800 volunteer hours so far.
Yeah. And that's the question there is how do we make this sustainable?
Well,
the business model. Or a business
plan. I mean, I don't know. It's a really good question. You mentioned academia, and I think not only do we see a lot of makerspace in academia, and certainly Neil's work with Fab Labs, but I'd love to see more cross-pollination between makerspaces and academia. And maybe you could talk a little bit about what your experience of working with Neil and for Bits and Atoms has been.
I think there's at least 3 areas where it's really valuable to have strong academic partnerships, and I'd love to hear what Tim and Sarah think as well. But the most obvious one are the resources that they have, right? Northeastern's been a great partner right now. There's a gentleman there, Ben McAllister, who runs one of their maker spaces, and our ability to prototype and get, say aluminum parts made on their water jets, or whatnot, I think that's essential. So the resources, the physical resources that they have are really powerful. The other is their research capability, right? Early on, Neil Gershenfeld reached out to the Boston maker community and he invited us in and said, what are you working on? What are the not known problems, right? Or what are the problems that are sort of research driven that we could help you answer? And so to see their analysis of spun bond propylene, right? Yeah. And then, the trapping features of different products, and then how we could get things that were tested into that testing pipeline is huge. We could never stand that up. I mean, we could, but it would be so exhaustive of our resources that we wouldn't be able to focus on these other things that are more concrete. So having that research power behind us is amazing. And then the other piece that is so valuable is their ability to call networks, to call community actors together in a way that brings us around a bigger table. We're often so, our heads are on the ground. We have relationships with people we work with on a day-to-day basis. By definition, the greatest academic institutions have very broad community connections to different actors, whether it's industry, government, private sector, nonprofit sector. And we can work together within that framework in a way that is very hard to escape when we're focused on more sort of hand-to-mouth issues of organization survival. So those are 3 ways.
Tonight, I got an email from someone that I've talked with on masks from the medical side for the last few months. And she's been working with a group in South Africa, a different group from the one I've been working with. And their question was basically like, we have 150 thread count cotton. We know it's not perfect. How good is it? How do we verify thread count? That sort of question. And I pointed her to Cameron's work to show her, like, take a look at this SEM of a cotton t-shirt. And you can see that regardless of thread count, a piece of thread is made up of tons of much smaller strands, and thread count says nothing about that. And B, the real hole is between the weft and the warp.
Yeah.
So even if you have, 1,000 thread count, if it's not tightly woven, that gap's still going to be there. So out of that conversation, I posted to Neil's issue tracker to say, hey, I was thinking about ways that people can test filter efficacy locally. So, one technique is bubble point. So you can basically take a membrane that's submerged in water and put air pressure on one side. And if you measure what pressure you have to reach before you start seeing bubbles form on the other side of the membrane, you can infer something about the porosity of that filter. Yeah. So in the issue tracker, I said, can we come up with a way where we take, a soda bottle filled with air and a soda bottle filled with water and 3D print an adapter that holds a piece of filter between them, and we just put weights on the air bottle and get a rough, sense of what it takes, so that somebody who, somebody in Africa who says, like, this is the material we have. It's, it's all we can get. Can we at least figure out if it's better than nothing? Because the thing about filtration standards, like, for masks, knowing what standard has to be met is wildly different from having any sort of information on what you have to do to meet that standard. So having this academic connection, I think, lets us know, like, what's the upper limit? What's the best we can do? What are we shooting for? And then from there, work it down to, like, what's feasible, what's economical, what's deployable. I want to cut every single corner that I can cut safely. And it's so helpful to get the academic or the hospital clinical perspective that's, we're not cutting any corners. This is the best way to do it. Which
we could point to some work of being able to disseminate some of this information on us having set up the process. I'm almost done with a doc that shows almost any makerspace. So one of the things that I did immediately in setting up the gowns program was going through a series of what would it have been like to make this in any other makerspace, what tools might have been available. And so I've got a whole big set of documents to show, if you have this tool and it's at 40 inches wide, how do you set up the pattern? If it's at 60 inches wide, how do you set up the pattern? So I feel pretty ready to kind of disseminate this information nationally.